Today, I'm going to be talking about intelligent tools on the Nexus platform. To get started, the first thing we will want to do is navigate to an image that we want to annotate. So why might we want to use intelligent tools in the first place? So you may have seen on some of our other videos that manual annotation, particularly of many objects or complex masks, can be quite cumbersome. So with the benefit of intelligent tools, we're able to accelerate that process. So the first thing we will do for this image is create a new tag called chameleon, and we'll go ahead and select that. And now we'll use our flagship intelligent tool, Intellibrush. And as we can see from the tooltip, what we'll need to do is first select the tool and then use left and right clicks to quickly annotate a mask of an object. So here I've left clicked on the center of the chameleon, and we can see that it's done a really good job of highlighting the entire chameleon, including its small appendages on the right side as well. Now we also provide a few different settings. So if you go on the right and select Intel settings, we can even select a different method of output from what I just shown, which is the point and click, to a bounding box method in which you click and drag around the object that you want to annotate, and using that box will provide an annotation afterwards. You can also change the foundational model that is running underneath the hood to detect these objects. So we have our flagship Intellibrush, but we also utilize open source models such as SAM 2.0 to help you do these annotations depending on what you prefer. We also provide a commit method, which is the multi-object and single object. Now, this may not be so relevant in this case, but what this does is essentially either allow the creation of multiple annotations just from one Intellibrush session, or do its best to merge all the annotation objects together into one annotation, such that all objects created from Intellibrush are merged into a single object. We also have another tool that we can use in conjunction with Intellibrush or other annotation tools, which is our Edge Refinement tool. So if we see on the top left, we can select this Edge Refinement. And what this does, it will clean up the mask that was created and really try to do its best to align it to the actual object underneath with as much detail as possible. As you can see with this high definition image of the chameleon, even though the intelligent brush actually matches most of the mask to the spikes, some areas are still missing. And if we're really looking for that pixel perfect annotation, we might want to use this Edge Refinement tool. Finally, when using Intellibrush, you may get aberrant masks that don't exactly resemble the type of mask you're looking to create. In that case, you can, instead of just left-clicking to select regions of interest, you can also select to right-click areas. And by right-clicking areas, you can show the model what areas you want to exclude. So if we zoom in here and I right-click, then as you can see, the mask tightens up on that middle pupil area and excludes the rest of the eye because of the dots I placed around it. Next, we'll move to an image that better showcases the uses of a tool called Everything Mode. So we can select it from the right sidebar. Once Everything Mode finished processing, you'll see that we have a ton of different outlines of possible objects that you might want to annotate, which in this case of an image of a car park is all these objects and annotations created around cars. And you can see that all you have to do is select the outlines that you want, and it will create the annotations as needed. In the Intel settings, the options that you have are low density and high density. So this helps to either reduce or increase the processing time. High density allows for the pickup of more objects, whereas low density runs a little bit faster, but is a little bit less able to pick up small objects. And once you're done, all you have to do is confirm those annotations, and they will be produced as real annotations as you would from any other intelligent tool or manual annotation tool. Now we'll jump to the Shark video to show off a few other intelligent tool features. So the first thing we're going to show is our Model Assist feature. And the goal of Model Assist is to essentially iteratively accelerate your annotation process. So once you've annotated a set of images as we've done here, on all the frames of this shark, as well as other images. What we're able to do is train an initial model to detect these sharks and produce such annotations. And we can then deploy it on Datature. Once we've done that, we can go into assist settings and select that deployment. And then we can go on an arbitrary frame and image and select model assist, and it will run that image on our deployed model and then use the predictions as possible annotations that we can use for our dataset. Now, as you can see, the model is able to produce fairly good predictions, which will provide good annotations for our dataset. The goal of this tool is to accelerate and further this iterative process of training an initial model to detect objects, and then further allow you to spend your annotation time just refining these predictions rather than having to annotate everything from scratch. On the left here, we're able to change the confidence levels to either alter the predictions and then also select which annotations we want to keep and then commit them as needed. Next, I'm going to talk about our video intelligent tools. So we have a few of those, and the goal here is to reduce the time needed to annotate the same objects but over multiple frames. So we'll first start with the interpolation mode. So this is best served for less complex movement tasks, such as with a bounding box or with streamlined motion, such as these sharks sort of swimming in the same direction in the water. So here I'm using Intellibrush as a way to rapidly annotate bounding boxes, actually, by selecting box mode on the bottom. This is another way to use our intelligent tools, so we can also speed up the annotation process, not just for masks, but also for bounding boxes. And then next, we'll want to annotate another frame of the same object. So we'll do the same thing and use Intellibrush with box mode on to produce another bounding box at the end of this sequence of frames. And now you can see once I've annotated that, it's produced a series of bounding boxes for each frame that somewhat reflect the movements of the shark based on interpolated values between those bounding boxes. Although the predictions aren't perfect, what we're able to do is go ahead and modify the predictions by adding a new key point, and this keyframe will allow the model to better predict how the shark is moving and therefore improve the predictions. Next, we'll talk about tracking mode, which is more of an intelligent tool solution with an underlying model to facilitate this tracking. What this does is allows us to track multiple objects, and this is especially useful for tasks in which objects are sort of moving in erratic ways or in more complex movements with occlusion, which may cause more simple methods like interpolation to fail. So to use the tool, what we have to do is annotate an object, and then we select a frame that we should track all the way up to. So we'll select frame 269, and then we'll select to proceed. And now the tracking is in progress. So as you can see, the differences between tracking mode and interpolation mode are that tracking mode is a little bit slower, but is able to produce more robust results to erratic movements or more complex object shapes, whereas interpolation mode is fairly instant, but provides maybe less accurate predictions. As we can see, tracking mode is able to produce fairly accurate masks for each of these sharks in all the frames, which means that we no longer have to annotate 2 sharks over 40 frames, which would be a very tedious task. If we're unhappy with the predictions, what we can do is select a frame in which it has a poor prediction, and we're able to right-click and select to re-annotate certain objects and thus refine their predictions. And once we refine them, they'll be propagated to the rest of the predictions across all the other frames as well. So as we can see, there are some minor improvements that have been produced from refining our annotation. So once we're happy with it, we're able to just select commit. And what that will do is confirm those annotations as regular annotations produced by any annotation tool on the platform. We can exit the mode and see those annotations.